Thank you very much. Dzień dobry, everybody. That's about all Polish I can. My name is Tobias Menzel. I'm from a German-based company called Hydromet, and we are basically one of Europe's largest manufacturer of hydrological and meteorological equipment. And as such, I'm here today to tell you something about the measurement of precipitation, and of course you know about its importance. And we do this already for a long time, and we possess a large experience with the measurement of precipitation. And basically, I would like to introduce you two sensors today in my presentation. Well, the main reason why I'm here, obviously, it's again the same guy. It's always the same guy, and his name is climate change. So, of course, we have many influences already nowadays. We will have even more influences in the future of climate change. So we will have extremer temperatures, heavier rainfalls, especially in summertime. We will have more frequent stormwater events that can happen anywhere at any time with almost no notice. So it's really hard to predict such stormwater events. That means we will have much more pressure on our public sewer networks. Because they are not designed for such heavy rainfalls, and therefore our all motivation is kind of to minimize and to reduce risks and to minimize damage to material and humans. And therefore we are facing challenges in the future. Again, it was mentioned already a few times during many presentations yesterday and today. We need to have a better management of our sewage water channels. And of course, I'm standing here as a representative of a manufacturer of a measurement technique. Therefore, of course, my message is today, everything starts with measurements. So we need to install networks to get reliable, precise online data that we just can start our management process. And therefore, we need an increased number of stations. We need, because as you know, precipitation is spatially distributed. Therefore, the number of stations is also key to success. The more stations we have, the better data we get. And that helps us to achieve a higher degree of automation in our management, in our sewer network. We can couple it with hydraulic models. Everything to do or to enable us to have kind of timely warning of the emergency management agency and of course also of the public. Okay, therefore the key message today of my presentation, if you take only one thing with you from my speech, is the saying here, you just cannot manage what you cannot measure. Therefore, it's really, I want to emphasize the importance of measurement networks, especially if you're talking about sewer networks, the measurement of precipitation. And I want to start like at least saying some words or a few words about tipping buckets, because we heard already some information about tipping buckets. And me personally, I'm not a friend of tipping buckets because in my opinion, it's not state-of-the-art technology. And that's also my headline of my presentation. So tipping buckets are no state-of-the-art technology. And why is that? Because it is still a mechanical principle. So there is always some moving parts involved. We have the bucket that is tipping, and therefore, it's a kind of a small Tamagotchi. Everything that falls into the bucket, be it leaves or insects or bird excrements, can somehow influence or even block the filter. So you always have to take care of the device, as I mentioned, a small Tamagotchi demanding repeated and endless care by the operator. And furthermore, it's not a very accurate measurement system because you have losses, you make mistakes, losses especially during high precipitation events because of the spraying loss, but also if you're interested in low precipitation events, you always have evaporation losses because it just takes the time until the bucket tips, and in the meanwhile you lose precipitation. And not to mention like winter operation, because that's then again a drawback of tipping buckets, because they need to be heated obviously because it's a mechanical principle, and therefore they create their own microclimate around the precipitation gauge, and you also have large evaporation losses there. Therefore, another message, tipping buckets need more maintenance and provide less accurate data. The data somehow escaped the blue box, which was not my intention. Good. What else can you do then if you don't want to have tipping buckets in your networks? Of course, we have a solution available. It's a very smart sensor. It's already in the market since at least a decade. It's the third generation of the Odd Pluvio, which is a precipitation gauge, obviously, and it's using the weighing principle. So it's just a bucket, basically. I can show it you in this slide. You see here the Pluvio in its large shape, Pluvio 2L. If you remove the housing, you find the bucket, and the bucket, in this case, it has got a capacity of 1,500 millimeters of rainfall, of precipitation. And this bucket is just standing on a highly accurate weighing system. So everything that falls into the bucket is weighed every minute, and if the weight increases, it is recorded as precipitation, and therefore also you will get the readings. And what that device, of course, makes unique is it's also the highly complex and highly sophisticated filter algorithms inside the device. Because, of course, you have external influences like wind effects, you might have temperature effects, steep temperature gradients, and we developed over the years these complex algorithms to compensate those influences on the measurement system just in order to get reliable, precise, and accurate data. So, again, the benefits of the Pluvio. We don't have moving parts, which is really a main benefit. So nothing that somehow can be blocked or obstructed or kind of get in danger of not working anymore. It's very accurate due to the weighing principle. There's the WMO, the World Meteorological Organization. They conduct from time to time intercomparison tests, and every time the Pluvio is the reference. So all other manufacturers, all other measurement principles even have to be compared with the Pluvio, and they have to compete with Pluvio. We don't have heating losses in winter time because we only have to heat the ring here on top of the gauge of the Pluvio, and therefore it's a very low power consumption, and of course it's also lifetime calibration included, so you don't have to worry about this as long as you want to measure with it. Okay, just a short overview about the devices available. The main difference is the size of the bucket. So we have a small version, the Pluvio S, with a capacity of 400 millimeters of precipitation. Then we have a larger version, the Pluvio 2L, with a capacity of 1,500 millimeters of precipitation, and a special version developed for remote areas, for mountainous areas, with a catchment area of 400 square centimeters, but then having only a capacity of 750 millimeters of precipitation. So depending on your application, we can just pick one of those devices for your network. So now we know how to measure with the Pluvio, with the weighing principle. Now you want to get your data. You need a system. You need a complete station. Therefore, here a picture of an installation of a Pluvio 2S. And it's a sensor. Therefore, the Pluvio is a sensor. You have to connect it to a data logger. And the data logger is obviously, therefore it's called data logger. It's logging the data, and it's also transmitting the data, meaning you can connect any type of modem to the data logger, and you can transmit data if you want every 15 minutes, for example, or even every 5 minutes. So you can use like GSM data transmission, 3G, 4G, for example. You can use PSTN landline telephone connection. You can use radio transmission if you have a radio network. You can even use satellite data transmission. So really, depending on your preference or depending on what's available at the site, you just pick the right way of communication, the right method of communication. Then of course, the data has to be transmitted somewhere, and this can be just a PC, it can be a server, FTP server. It also can be a cloud-based solution for publishing of the data. ODD offers a service that's called Hydromet Cloud, but of course, you can also use other solutions, for example, the solution offered by RETENCJAPL, RainBrain, which is also compatible to the data transmitted by the odd loggers and odd plurials. Okay, secondly, the second device I would like to introduce is it's again a different device. It's a laser-based measurement device. It's called Parseval, and Parseval basically stands for particle size and velocity, meaning that this device measures really the size and the fall velocity of each and every particle that falls through that laser beam that is created here. So we have a laser in this housing, a transmitter, and we have a receiver, and this laser is generating here a flat beam of light, which you cannot see if you're there because it's laser, and every drop that falls through the beam somehow changes the signal. It's the so-called extinction principle, and from the degree of extinction and from the duration of the signal, you can conclude particle size and fall velocity. And with that information, of course, you can start your calculations. You can also derive, of course, intensity, but you also can, what is most important, I explained it already, so we have the lasers. Here we have a three-dimensional display of the drop spectrum, meaning we have here on one axis we have the diameter of the drops, and here we have the fall velocity, and the columns here of course represent the accumulation of each drops. And so each precipitation event generates its own pattern, has got its own characteristics, and with that information the software is able to determine whether it's just raining, whether it's hailing, whether there is snowfall, or other types of precipitation. So you really can differentiate between the different types of precipitation, as it is showed here again. Again, we have here diameters in millimeter, we have fall velocity, and a raindrop obviously usually is of a smaller size and with a high fall velocity, and a snowflake, for example, has got a larger diameter and is much slower. And from this pattern, you can derive or distinguish the different types of precipitation, which are mentioned here: drizzle, rain, ice pellets, hail, snow, and also mixed precipitation. So this, of course, also for sewage water systems, very helpful information, because you just don't get the amount of rainfall. You also know if it's effective for your runoff already now, or will become effective only later, because it's solid precipitation right now. And additionally, what you also can derive from this Parseval system is a parameter which is especially important for the calibration of the big weather radar systems. It's a parameter called radar reflectivity, Z/R ratio, and this parameter is also needed from the operators of the large radars for the quantification of the information. This means if you calibrate your weather radar information, your weather radar data with ground-based Parseval stations, you get much better information about the quantity and the spatial distribution of your precipitation. Good news is it's already arrived in Poland, Parseval, so that's an example of an installation in the city of Rumia. Okay. Now I want to finalize my presentation with a very fine example of the city of St. Petersburg in Russia. You see the nice skyline here, it's almost as pretty as Gdansk. They were facing basically the same problem. They have a kind of sewer network which is not really managed properly. They had problems with floodings, and they also see a trend that actually, or for the time being, about 20% of the wastewater that arrives at the wastewater treatment plants comes from surface water runoff, and they expect that number to increase in the future. On the one hand, because of the general decline of water consumption, and on the other hand, of course, because of the ongoing process of urbanization. Therefore, this number will rise, and they just want to be prepared, because it doesn't help much if you know it's in general 20%, because it can be anything between 0% and almost 100%. And therefore, they also need that information of precipitation for the management, basically of the treatment plants, for the management of excessive waters, which they collect in their sewage, in their sewer system. And therefore, they decided to install they call it computer-aided monitoring network, consisting of 34 precipitation stations plus 7 weather stations in the area of the city of St. Petersburg. You see 3 pictures. First one is, well, a typical installation. You see the Pluvio here. They decided for the large version, the Pluvio 2L. We have the windshield here to minimize wind effects. And here in this stainless steel enclosure, we have the data logger and the communication inside. So from these stations, or another example looks similar because it's the same concept, obviously. From this station, data is transmitted every 15 minutes to a web platform, which I will show you soon. But there is, as I mentioned, 7 weather stations included, and at those 7 stations, there is an additional sensor, which is a small, compact MET sensor, basically. So it's able to measure simultaneously parameters like air temperature, humidity, and also air pressure. So and all that data, as I mentioned, is then transmitted to a web portal. You see here it's also accessible for the public. You see here the red triangles represent the locations of the stations. So in the whole area of St. Petersburg, St. Petersburg is here. The whole area of St. Petersburg, you have those 34 stations. And if you click another button there, then you also get the record of the historical data. You see here they chose this type of visualization. You can click one of those buckets here, and then you get the graph and the historical record of the data. So this is, of course, an approach we really like to see, because it's a modern network. It's the first of its kind in Russia, even. And we hope it's a shining example for many other cities to follow, maybe also, of course, cities in Poland. We also are aware that measurement is just the first step of a long journey, because you have to put in a lot of brain knowledge, expertise, modeling, and so on into the system until you really get a proper management done of the sewer network. But we are ready to help there. And again, one statement, one message. You see here the test field. Maybe you don't have to use like 25 rain gauges in one location, but if you want, of course you can, because my statement, you can't manage what you can't measure. Thank you very much.